So here we're given a data set, and it's asking us to sketch and label the normal curve, and then find out within how many standard deviations all the values fall. So the first thing we would do is you would use your calculator and you would calculate the mean and the standard deviation. So I'm just going to tell you what they are. The mean is 82 and the standard deviation is 19.58. So the first thing I'm going to do is I'm going to label my normal curve. I'm going to put the numbers on that bottom axis so that I can figure out where all of my numbers would actually fall. So the mean is 82. If I'm going up, I'm going to be adding 19.58 each time. So I'm going to have 101.58, 121.16, and 140.74. And then going to the left, I would have 62.42, 42.84, and 23.26. And then just because it's going to be relevant in just a minute, I'm going to label on my normal curve. The very middle is my mean, and then I'm going to write 1s, 2s, and 3s to represent how many standard deviations those are, and then negative 1s, negative 2s, negative 3s. Okay, so we have done steps 1 and 2 now from the previous slide. Now we're going to mark the places where the smallest and largest data points fall. So we need to go back to our list, and we need to identify the smallest point and the largest. So the smallest is 52, and the largest number on the list is 105. So now going back to my normal curve, I need to figure out where would 52 fall. So 52 would be between 42 and 62. So I'm going to put just a dot here and mark it 52. And for my largest, 105 would fall between 101 and 121. So I'm going to put a dot here for 105. And then for step 4, last step, so that this is going to be our answer, we're going to count outward from the mean. So I'm looking to see on either side what is the farthest away it gets from the mean, how many standard deviations. So if I'm counting from the mean here, this would be 1 standard deviation out, and then 2 standard deviations. So 105 is 2 standard deviations away from the mean, because it's in the section that is 2 standard deviations away. And then on the other side, 52, so if I go to the left, that's 1 standard deviation, and then here's my second standard deviation. So this one also is 2 standard deviations. So they're the same, so my answer is definitely 2 standard deviations away. This is example 2. It's the same exact question, but now we have different data. So the first thing you want to do, step 1, is find the sample mean and the sample standard deviation, which you can do using your calculator. So the sample mean is 11.8, and the standard deviation is 1.5. Step 2, we need to draw and label the normal curve. So the mean is 11.8. That goes in the middle. Going to the right, I'm going to have 13.3. And by the way, I'm adding 1.5 to get these numbers. 14.8 and 16.3. Going to the left, I would have 10.3, 8.8, and 7.3. And then again, I'm going to label on the top that this is the mean, 1 standard deviation, 2 and 3, and then 1 standard deviation to the left, 2 to the left, 3 to the left. Okay, so at this point, I need to move on to step 3. I need to identify the smallest and largest values in our data set. The smallest value looks like 9.8. and the largest is 14.2. So now I need to figure out where those numbers would fall in our example here on our normal curve. 9.8 falls between 8.8 and 10.3. So here's 9.8. And 14.2 would fall between 13.3 and 14.8. So this problem is almost identical, other than the numbers being different, because we're within 2 standard deviations. So it's 2 to the right and 2 to the left. So my answer is 2. Now, it hasn't happened in either of these problems, but it is possible. I'm going to just draw a real quick picture down here. It is possible that you have a normal curve, and you might have one set of data, your smaller set of data might fall 1 standard deviation away, and your larger set of data might be 3 standard deviations away. So this is your mean, 1, 2, 3, -1, -2, -3. So if you have something like this happen, where they're not symmetrical, so in the past 2 examples, they've both been the same number of standard deviations away. If they are not symmetrical, you have to look at the farther one. So even though this one right here is only 1 standard deviation away, this one is 3 standard deviations away. So your answer is the larger distance. So the answer to this one would be 3 standard deviations.